Hi everyone! Today we are going to talk about the special points of a graph. In this video you're going to learn how to identify those special points on a graph, and we're talking about a lot of vocabulary today. We're going to look at zeros, x and y intercepts, turning points, and the extrema. There are 4 different kinds of extrema. There's the relative minimums, relative maximums, absolute minimums, and absolute maximums. Let's go ahead and get into talking about this vocabulary first. So first, when we're looking at an x-intercept, that's the point where the graph crosses the x-axis. Remember, the x-axis is the horizontal line, and if I just draw a rough sketch real quick here, something like that, this graph has one x-intercept, this point here where it crosses that horizontal line, the x-axis. Now, the x-intercept is also going to sometimes be called a couple of other vocabulary words too that I want you to know. In addition to being called an x-intercept, sometimes you're going to hear it called the zero of a function, or the root of an equation, or the solution to an equation. And the thing to keep in mind here is that all 4 of these vocab words, x-intercept, zero, root, and solution, mean the same thing, where it crosses the x-axis. The y-intercept is the point where the graph crosses the y-axis. So remember the vertical line, that is our y-axis, and wherever the graph crosses and intersects with that y-axis, that is our y-intercept. When we talk about turning points, that just means the graph changes the direction. So if we start on the left side of the graph and we follow along this line, it's going uphill. It is increasing. So then when we get up to this peak here, it changes and starts going downhill. That means that this top point here, where it changes directions, that's a turning point. Notice that this graph I've drawn also has another one. After it goes downhill, it changes and starts going back uphill. So this graph has 2 turning points. Now, those turning points have special names as well. So we have this one, which is at the top of a hill, and this one, which is down in the bottom of a valley. Those are called minimums and maximums. Now, whenever these minimums and maximums happen, sometimes they are going to be called relatives, and sometimes they're going to be called absolutes. So, because it changes direction, the function here, that means that this blue point is a relative maximum, because relative to the other ordered pairs on this line that are close by, it's high up. So, this is high, or higher than all of those points there, so it's a relative maximum. This point down here is relatively low because compared to the other ordered pairs close to it, it's low. So we have a relative maximum and a relative minimum in this graph. Now, I do also very quickly want to point out that sometimes instead of the word relative, the word local is used. These are synonyms for one another. They mean pretty much the same thing when you're going to see them in this class. So if you're asked for a local maximum, that means the same thing as being asked for a relative maximum. It is a point that is relatively high or locally high compared to the other ordered pairs. If you're asked for a local minimum, it's the same thing as a relative minimum. All right, so then if we have absolute maxes and mins, these are the very highest and very lowest points on the graph. So I'm going to change my graph here. Actually, you know what? I'm just going to draw another one because I do want to talk about that one with these just a smidgen more. So let's draw another quick sketch down here. Let's say I have a graph that does something like that. All right, so just a quick recap. I have a turning point, a turning point, and a turning point, right? Because it changes from increasing to decreasing, and then it goes back uphill, it changes, and then it goes downhill again. All right, so I've got 3 turning points, which means I have 3 places that I'm going to look at closely here. So an absolute maximum is absolutely positively the highest point on the graph. We're looking for the top of the graph. So if I look at this graph, we have two relative maximums because there are two places where the graph changes directions and it looks like the top of two hills. But this hill, if you will, is higher than this other one, which means that because no point on this line is higher than this turning point, that turning point is the absolute maximum. It is the highest point of the graph. So that is our absolute max. For an absolute min, notice that on this graph, the graph goes down forever on the left and it keeps going down forever on the right. That means I can't pick a lowest point. I can't say, okay, this is the lowest point on the graph because there are all of these other ordered pairs on this line as it keeps going infinitely down to negative infinity. So for this graph, there would be none. There would be no absolute minimum. If we look back up at this top graph for a moment, let's talk about that bottom part first, the lowest point on the graph. Now we do have turning points here and here. However, this arrow on the left-hand side goes down to negative infinity. That means that there's no lowest point because this line keeps going down forever. If we look over for our absolute maximum, this line goes up forever on the right. That means there's no absolute maximum because this goes infinitely up and up and up and up. So in this graph, we have two turning points, a relative maximum and a relative minimum, but no absolute maxes or minimums because there's no bottom and there's no top. All right, let's look at a couple of examples where we're actually finding the ordered pairs for these. So in this first one, we're asked to identify the special points for the function graph. So x-intercepts mean that we are looking for where it crosses the x-axis. I see 2 points. I see this one and I see this one, so I'm going to list those two ordered pairs. The one on the left is -3, 0. The one on the right is 1, 0. Remember that zeros, roots, and solutions are all the same thing as an x-intercept. So my zeros of the function are going to be those x-intercepts as well. Whoops. My roots are also going to be -3, 0 and 1, 0. And my solutions are going to be -3, 0, 1, 0. All four of those vocabulary words mean the same thing. They're asking for the same part of the graph. All right, so let's talk y-intercept now. The y-intercept is where the graph crosses the y-axis. So we're looking at this point here, and that point is 0, -3. Now, it is just a coincidence that the x-intercept and the y-intercept are the reverse of each other. That will likely often not be the case, so don't lean too much on that. You're looking at on this y-axis where the graph crosses that line. All right, let's talk turning points so we can talk minimums and maximums. Looking at this graph, it starts on the left going downhill, and then it gets to this bottom point, and then it starts going back uphill. So that means we have one turning point and only one turning point because it only changes directions one time. That turning point is at -1, -4. So that is our single turning point. Now, because there's only one turning point, there's going to be only one relative, and we have to figure out, is it a minimum or a maximum? This turning point is low compared to the rest of the graph, which means that we are looking at a minimum. It's down towards the bottom. So I'm going to write that same turning point as my relative minimum. And for my relative maximum, because there's no turning point that looks like that, where it's up high, I'm going to write none. Now, for absolute mins and max, remember this is the top and the bottom. The absolute top and the absolute bottom. Now on the graph we're looking at right now, see the two arrows that are going up forever? That means there are no tops because these go infinitely up to positive infinity. So for absolute maximums, we're looking for the very top. There isn't a very top. It goes up forever. If we're looking for an absolute minimum, then we're looking for the very bottom. And if I'm looking for the bottom, this point that I had said was a turning point is also the very lowest that the graph goes. So that point is going to be my bottom, my absolute minimum. Okay, let's look at one more example. This one is a little bit different. If we're looking for x-intercepts, we're still just looking for where it crosses the x-axis. That's this point here, which is -3, 0. If we're looking for a 0, that's just an x-intercept. If we're looking for the y-intercept, that's where it crosses the y-axis, so that's 0, 1. Now turning points are where things get a little bit different. Notice if I start on the left, like always, and I follow this graph, I am going uphill the entire way. It is only increasing. It never changes to go downhill. That means there are no turning points. And if there are no turning points, there can't be any relative minimums or maximums, because relative means that it changes directions and creates either a little hill or a little valley. It doesn't do either of those things. Now, absolute minimums and maximums, I'm looking for the bottom and the top here, not the turning points. So, for the absolute maximum, I'm looking for a top. This line keeps going uphill forever. It's slow, it's not going up as quickly as some of the other ones, but it's still continuing to go up and up and up and up as we go further and further and further up the graph. So this one has no absolute maximums. However, there is a bottom, an absolute minimum. This point here is the very bottom of the line. That means that at -4, -1, we have an absolute minimum. Okay, so if we're given a graph and we're just asked to identify those points, it's super easy, hopefully, once you get a handle on that vocab. That is not, however, always how it's going to be. Sometimes we're going to have to use a graphing tool. Did you notice on all of these graphs that there were no fractions? They were all nice points that were easy to identify. That's not always the case this year. So if we look at this next graph, you can see that this x-intercept is not going to be a pretty number. It's going to be a fraction. If we look at this relative maximum, that's close to a nice ordered pair, but it is going to be a fraction. This one looks pretty good. We're going to check that just to make sure that it is indeed that ordered pair. If we look at the y-intercept, that also looks like it's going to be okay. I'll show you how to check that as well, just in case. Alright, so let's look at these two different ways. I'm going to show you how to do this in the calculator, but also on Desmos, because you'll be using different graphing tools for different things. So first, I'm going to pull up my graphing calculator here. I'm going to go to the y equals and type in my equation. So this is x raised to the third power, so I'm going to hit x. Then I'm going to use this little upper arrow called a caret to get up into the exponent, put a 3. I'm going to hit my right arrow because do you see how it's still up in that exponent? I don't want to stay there, so I'm going to go back down and hit minus x. You can either hit up to, or you can use the x squared button to automatically get there, and then minus x plus 3. Okay, so my graph looks, yep, like the one that I have on my paper, so that's good. Let's see what we're asked for now. First, we're asked for the x-intercept, which is where it crosses the x-axis. Now, this is not a pretty point, so we're going to have to do a little bit of work for it. Remember that x-intercept and zeros are the same thing. Here's where this gets really nice. If we go to second trace, because we want to calculate where our x-intercept is, look at these options and notice that number 2 is for a 0. So we can find the 0 or find the x-intercept of the graph in the calculator. So I'm going to hit 2. You can also scroll down and hit enter. And it's going to ask me some questions. It has not told me the answer yet. It's going to ask me for the left bound. Now what that means is we are going to put the cursor on the left-hand side of this x-intercept that we see. So I'm going to move the cursor, that blinking black x, so that it is on the left of the x-intercept. When I hit enter here, it's going to put this dotted line. That dotted line should be on the left side of the point that you're trying to find. It then asks me for the right bound. So I'm going to move the cursor over to the right and put it on the right hand side. I hit enter again. Notice that my x-intercept is in between those two dotted lines. That is essential. You will get an error message if you put these two dotted lines not on the correct side of the 0. Then for guess, we're going to move it back down to where the x-intercept looks to be and hit enter. Then it's going to calculate that 0 for us because we narrowed the field, we bounded it on each side, and that gives us our answer. So we're going to round to 2 decimal places according to the directions here. So that means we are looking at, for our 0, negative 1.359, which rounds up to 0.36, and the y value is 0. Notice it gives you the x and the y of the ordered pair. Now, because my x-intercepts and my zeros are the same, that also gave me the answer to that question. Now, to find the y-intercept, if I go to second trace again, there isn't a y-intercept. There's the intersection, but that is something else. It's something for another day. So what we're going to do is go to the table by hitting second graph, because we know that the y-intercept is going to be 0, something, which means that we can look at the table and see where that ordered pair is 0, and then some y value is given to us. We're expecting it to be 0, 3, and it is. 0, 3 is that first thing that comes up. You might need to scroll a little bit if your zoom is in a different place, but in my case I didn't need to, so I'm just going to change my settings here and write that in. Okay, so now let's talk about the turning points. We identified 2 turning points, this one up here and this one down here. So let's go back into our calculator again, and for our graph we're going to have to do this 2 times, one for each of the 2 turning points. I'm going to hit second trace again. Notice that you have minimum and maximum here. So let's do the maximum first, this one that's over on the left. So I'm going to hit 4. And then it's going to ask me the same questions that it asked before. Left bound means that I need to put the cursor to the left of this maximum that I'm trying to find. It's there right now, so I'm going to go ahead and hit enter. And then I need to do a right bound, so I'm going to move the cursor over to the right, just so that it's on the other side of that hill, and hit enter. So now my maximum, my relative maximum, is in between those 2 lines. So I'm going to move the cursor back to the top of the hill, hit enter for my guess, and then it tells me that my turning point, my relative maximum, I'm going to answer both of these at the same time, is at negative 0.33, 3.185. That rounds up, so it's going to be a 9. And we just found that maximum, so I'm also going to write that turning point for this relative maximum here. Okay, so now we need to do the relative minimum and that second turning point. We are not done answering this question yet. So to find this turning point here, that relative minimum, I'm going to go back to second trace. I'm going to choose number 3 for minimum, and I'm going to answer the questions again. The left bound means put the cursor on the left-hand side of the minimum. Right bound means move it over to the right and hit enter. And then for the guess, I put it directly on where I think that minimum is. I hit enter, and it tells me that ordered pair is going to be 1.00 and 2. Notice when I was looking at this graph, that looks really, really close. It looks like 1, 2. It's not quite there because it has these other values, but we were pretty close if we were estimating, saying 1, 2 would have been fine. So for my relative minimum, I'm also going to put 1.00 and 2. Now we need to talk about absolute mins and maxes, and then we'll be all set. If we're looking for maximum, that's the top. We have a hill here, but it's not the top of the graph because this keeps going on forever. All of these ordered pairs are also on the graph. So our relative maximum isn't the tallest point. It goes up forever, which means there is no absolute maximum. The same thing happens with the absolute minimum. Yes, we have a relative minimum, but it's not the bottom of the graph because this side of the graph keeps going down forever. So there's also no ordered pair to write there. Okay, so I have removed all of that because the other way that I want to show you how to do this, instead of using a graphing calculator, we can also use Desmos, and Desmos is really neat. So let me end this show and pull up Desmos. I went to desmos.com and I'm going to hit Start Graphing. I am going to type my equation back into the bar over here. You have a keyboard over on the side, so you can use it, or you can just use your keyboard. So I'm going to attach my keyboard real quick and type y is equal to x raised to the third power, moving down out of my exponent, minus x raised to the second power, again hitting right to move down out of my exponent, minus x, and then plus 3. Okay, so I have my equation here. Pardon me while I remove my keyboard again. Okay, so I have my graph, and you'll notice that there are these little gray points. Here's what's really great. If I click on these points, it gives me the value, and that's my x-intercept. If I click on this point, it gives me the value of my y-intercept. If I click on this one, that tells me my turning point and relative maximum. And if I click on this one, it tells me my turning point, which is a relative minimum. So if you have access to Desmos and you have these kind of uglier numbers to deal with, you can very quickly get those answers just by correctly typing in your equation and then clicking on the special points, which it even kind of hints at. I will point out that you can also click anywhere you want to find another point if there's something that it's not hinting at that might be helpful to you. So you can get all of these answers as well, those ordered pairs, by using Desmos. All right, so now we have identified the special points, which include zeros, x and y intercepts, turning points, and the extrema, both relative and absolute, mins and maxes. There are 2 Now You Try problems that I'd like for you to take a moment to try.